What are they doing each time? They're adding or subtracting something, right? So for geometric sequences, do you remember what I told you yesterday?
Addition, or not addition, multiplication.
Multiplying, right? So instead of adding some number each time, they're multiplying some number each time. So that's going to be our definition up here. So a sequence of numbers in which the ratio. So today we're using an R instead of a D for that common difference. It's a common ratio. So for your geometric sequence, it's a sequence of numbers in which the ratio R remains constant. So again, you're just multiplying by some number each time instead. And your common ratio is found by dividing each term by its previous term. And again, it's just that number that you multiplied. Questions? Alright, so we're going to look at the first section down there. So for these, we're just going to look at the sequence, decide if it's geometric or not. If it is, we're going to say what the common ratio was. So what did they multiply each time to get that sequence? So for number one, we've got 2, 10, 50, 250. What do we think? They could multiply by 5, and that would work out. Okay, so is it geometric? Yes, and that ratio we said was going to be 5. Is that right? You got it. So if you look at number 2, we've got 135, 45, 15, 5. Dividing by 3. So we'll say yes, it's geometric, but we don't want to say that R is, how can we write that? Because it's times something. So how could you write dividing by 3 but with multiplication? Times 1/3. So your R value is 1/3. So if it's ever getting smaller, or if you're thinking, oh, that's just dividing by 3 or that's dividing by 2, just make it a fraction. So 1/3 or 1/2. What if it was dividing by 5? 1/5. Does that make sense? Okay. Sometimes it's going to be hard to see what that common ratio is. So to check it, you can do what it said up here, divide each term by its previous term. So like 5 divided by 15, simplify that fraction, you'd get 1/3, so that would get you there as well. Is that okay? Because sometimes it might be a crazy fraction, like 2/3 or something that you wouldn't pick up on just by looking at it, okay? Looking at number 3, 6, 18, 24, 30. What do you think? How do you get from 6 to 18? Times 3? Or what else could you do? Well, I don't know. What about 18 to 24? Add 6. So we're timesing something, adding something. Is this going to be geometric? No. All right, what about number 4? Good. So, yes, it's geometric. Anytime it flip-flops your signs back and forth between positive and negative, your ratio has to be negative. So this is going to be a -2. Questions on that one? Alright, number 5, we got 80, negative 40, 20, negative 10. Is it geometric?
Yes.
Yes. So we know that it's geometric. Your R value, is it going to be positive or negative?
Negative.
Why? Because it flip-flops back and forth between positive and negative. So what are they multiplying by?
1/2.
They're dividing by 2, so multiplying by 1/2. But okay? And the last one there, number 6, we've got negative 9, negative 36, negative 144, negative 576. Oh my goodness, what are they doing?
All 4.
Times 4, does that work out? Let me check that. Okay, so yes, it's geometric. Is our R value positive or negative?
All.
Positive, good, because it starts negative and it stays negative the whole time. Is that okay? So the next section, we're just completing that sequence. So you've got to figure out what they're doing and then do it 3 more times. So from 7 to negative 21, what did they do? Times by negative 3, so 63 times negative 3. What do we get? Then what are you going to do to get the next one? Times negative 3. What do we get? How are you going to get the last term? Multiply by negative 3. What do we end up getting? Is that okay? Alright, next one. This is a little tricky. From 3,072 to 768. What do they do? How'd y'all get that?
I did 3,000.
Divide it. So this is where I was talking, like, if you're not sure just by looking at it what it should be, we could divide. So do 768 divided by 3,072. I can't put numbers. And that'll give you that 1/4. So that's what they multiply by. Does that make any sense? Okay. So what's 192 times 1/4?
48.
And what's 48 times 1/4?
12.
And 12 times 1/4? What would the next term be? 3/4, yeah. Can we put that one on there? Just for fun. Is that alright? Alright, so line number 9. We got 842. What are they doing? Divided by 2. What's 2 divided by 2? What's 1 divided by 2? What is 1/2 divided by 2? There you go. And the last ones there, we've got negative 5, negative 25, negative 125. What are they doing? Times 5. So what's negative 125 times 5? Times negative 5 again. Times negative 5 one more time. Is it 265 or 625?
625.
That's okay. Questions on any of those? So y'all remember yesterday how we said that if you wanted to find like the 100th term of the sequence, you could just keep adding whatever. And so like same idea here, if we want to find the 100th term of the sequence, we could just keep multiplying by whatever. But there's a rule, a little shortcut that's going to make it easier again. So our rule today is a sub n equals a sub 1 times r to the n minus 1. Do y'all remember what a sub 1 stands for? Yeah. That's a multiplying times. And then your R is your common ratio. And what does N stand for? Same thing it did yesterday. Your term number. I mean, N is number, right? So that's where that comes from. So ready to try some?
Yeah.
So guys, essentially the exact same thing that we did yesterday, you just have a different rule now. So for the first one over here, we've got 3, 9, 27. So you need your first term and you need your common ratio so that we can write our rule for the nth term, our general rule for the sequence. So what is your first term?
3.
And what is our common ratio? What are they multiplying each time? 3. Okay. So when we go write our rule, we're going to have a sub n equals, in place of our first term, a sub 1, what are we putting?
3.
And in place of r, what are we putting?
3.
And then you have to the n minus 1. Is that okay? Now this wants us to find the 7th term, a sub 7. So when we do that, you're just plugging in a 7 for n. So we'll say a sub 7 equals 3 times 3 to the 7 minus 1. And what is 7 minus 1? So this is really just 3 times 3 to the 6th. And you can type that in your calculator. Yeah, you can type that in. You can type it in at this point if you want. Or you can simplify it first. Either way is fine. Yep. Questions? So we're okay? Alright, same idea for the next one. You've got to have your first term and your r. So a sub 1, what is that? And your r value, what are they multiplying each time? 5 or negative 5? Why is it negative 5? Because it flip-flops between positive and negative. So when we go write our rule, you're going to have a sub n equals, your first term was what? Negative 4. And then our r value was what? Negative 5 to the n minus 1. Is that alright? And so there's not any simplifying that we have to do with your general rule like we did yesterday. So once you've got it plugged in or set up like that, you're good to go. Again, we want to find the 7th term, so we'll find a sub 7. And then we're going to do negative 4, parentheses, negative 5 to the 7 minus 1. And you can type that straight into your calculator if you want. You could go ahead and do the 7 minus 1 if you want. Either way, you should still get the same answer. What do we end up getting? Positive or negative? Are you sure? Should be negative. Yeah, it should be negative. Because when you do negative 5 to the 6th, it's a even exponent, so that's going to become positive. Does that make sense? And then you're doing that number, that positive number, times a negative 4. So your final answer should be negative. Does that make any sense? Yes, no, maybe. If you don't use parentheses, then it won't come out right. So that's why we write it with parentheses here too. You all right? Alright, so we've got a couple more to do, 6 more to do. Do y'all want to pick different numbers for your a sub whatever? So like I said, if I need a 7th term, what term do y'all want to find?
8.
Give me a number.
8.
Okay, so 8, another one.
12.
96.
No,
Wait,
that's not a number.
Alright, is that alright? We okay?
Yeah.
Yeah.
Y'all can do all those on your own? If you didn't catch those numbers, I'll try to there you go. Is that okay?
Yeah.
Alright, so you're writing your general rule with the n in there, and you're going to find those term numbers. Okay?
Yeah.
Alright, so for the first one, what was our A1? And what was your R? So your formula should have been A sub n equals what?
400 times 1/2 81.
1/2 to the n minus 1. When we go do our 8th term, we'll have 400, 1/2 to the 8 minus 1, yeah? When we typed that one in, we didn't get an awful answer. I had 25 over 8, so I don't know what that was as a decimal. Is that okay? All right, questions on that one at all? Cool beans. So for number 14, what was your A1 value?
1.
Your R, your common ratio? 5. So set up your formula. You're going to have A sub n equals what?
Parentheses 5.
Parentheses 5
Oh, or to the
to the
17th.
n minus 1.
So when we want to find the 18th term, when you type this in your calculator, you've got 1, 5 to the 18 minus 1. Is that okay?
17.
So it is just 17. And when you type that in your calculator, oh,
76293453125.
a big number. I'm not going to write it. We okay with that? All right. So for number 15, what was your A1?
-1.
What was your R?
4.
When you set up your equation, you have A sub n equals what?
-1 times 4 n minus 1.
To the n minus 1. We wanted to find the 24th term. So you would do -1 times 4 to the 24 minus 1. And when you type that one in your calculator, it was like -703687441776664.
Yes.
Yes,
Precisely.
precisely. I'm not writing that down. We good?
It's okay, you don't have to.
Okay, thanks. That'll be a lot of work. All right, so for number 16, what is our A1 value?
729.
729. Our R, the common ratio. Good, -1/3. So when we go write our formula, A sub n equals what?
-1.
What?
Oh, wait. That's it, 7.
So when you want to find your 30, wait, no, we wanted the 12th term. Sorry, I don't know why I thought it was 30 something. So yes, your exponent would be 11.
And that's -0.004115.
So again, wait, for that one, I got just, it's -1 over 234.
Yeah, but then you,
As a decimal, you get whatever. I'm going to leave it as -1 over 234, 43, sorry, because I can write that. That's manageable. Is that okay? I'm not writing the 20-digit numbers.
better at 17 and 8.
Oh, I'm so pumped. So for 17, what was your A1?
6.
And your R value? -2. When we write our function, you're going to have A sub n equals what?
6, parentheses, -2,
So we wanted the 96th term. And when we type that one in, good grief.
2, 3, 7, 6, 8, 4, 4, 8, 7, 5, 4, 2, 7, 9, 3, 0, 1, 2, 7, 8, 0, 6, 3, 1, 8, 7. Y'all were doing so good. Those last are pretty good. 0, 0, 8.
Yeah, that. You get that. Are we okay?
Yeah.
Do you have questions on anything so far, y'all?
Do we have to do it?
Yes, we have to do 18. What's your A sub 1?
8.
What was your R value?
3 halves.
It was what?
3 halves.
3 halves.
What?
How do we find that?
Equals off.
12 divided by 8, or 18 divided by 12.
Yes.
Yeah?
Yep.
So when you do that, that's where the 3 over 2 comes from. So set up your function. You're going to have A sub n equals what?
8 parentheses, 3 halves, 102 minus 1.
We wanted to find our 102nd term. We have lost our minds. 3 over 2 to the 102 minus 1. And that one's awful. Literally awful.
That's a wonderful one.
Awful. That's what you get.
We got 5, 1, 4, 2, 3, 0, 1, 7.
Well, that's wrong. It should be like 1546 blah 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 over 3169 blah 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 blah. Okay,
Close enough.
close enough. It's fine. Questions? Are we all right with those?
Yeah.
So what's the moral for like geometric sequences? What do you notice?
Keep it low.
Use a small number.
Use a small number. Yeah, because what happens?
It gets crazy.
It gets big fast.
Oh my gosh, wait, it gets really big really fast?
Exponential growth.
Exponential growth. Or what else?
Exponential decay.
You got it. Is that okay?
Yeah.
Do we see the connections?
Yes, I
Are we
do.
making connections here? Yeah? Okay. So, fun fact, this is science for you. In your brain, you have little, like, things that fire off messages. And when you make connections, like we just did right now, they go, and they, like, connect. Yeah, so that just happened. Your brain just did stuff.
Wait, they did what?
You get it once, that's it. It's recorded, so if you want to watch it, go back on YouTube, okay?
Yo, we can see your face.
Okay, it's okay.
Turn
We
the
don't need
camera.
Nope. All right, so for the next one here, this table shows the car's value after 3 years after it's purchased. This already sounds a lot like what?
Exponential decay.
Exponential decay, right? We did this a bunch, okay? So we want to write a rule to represent our car's depreciation. And what does depreciation mean again?
Going down.
Going down, losing value, right? So this is going to be growth or decay?
Okay, because
Decay. Okay, good. So we're going to use the rule that we've been using, which, y'all, is very, very, very similar to our exponential decay formula anyway, right? Because that a sub 1 was our first term. When we were talking like exponential decay, it's where you started, right? So where did we start here?
10,000.
10,000. So I'm going to write that a sub 1 is going to be 10,000. 10, what did I do? Okay. I need enough zeros there. So we've got to figure out that R, that common ratio. So like it was our growth or decay factor. But for us this time, we can just divide to find that. So like 8,000 divided by 10,000, which is basically just 8 over 10. So reduce that fraction when you get
4 over 5. 4 over 5. 4 over 5.
We said it's decay, right? So it has to be less than 1. So does 5 over 4 work?
Nope.
Okay.
That's not G.
Catherine, I need you to go back to your seat. So when we're writing our rule, you're going to have a sub n equals what?
10,000.
10,000. Inside parentheses, what are we putting?
4 over 5.
4, 5. And your exponent?
N minus 1.
So very, very, very similar to exponential growth and decay. Yeah?
Yeah.
We want to know the value of the car after 10 years. So how are you going to do that?
Plug in.
Plug a 10 in for n. So we're going to say a sub 10 equals 10,000 times 4 over 5 to the 10 minus 1.
What?
So what do we end up getting?
1,342.8.
Questions? We all right?
Nope.
Wait.
Yeah, sorry. That okay?
Why is there speaking the lake? That's what
I know. Sorry. If I could take it out, I would. Let's see. All right. Questions on any of that? We okay?
Yes.
All right. We're not gonna do out in the hall like we did